A rotorcraft or rotary-wing aircraft is a heavier-than-air aircraft with rotary wings or rotor blades, which generate lift by rotating around a vertical mast. As depicted in the figure, there are two types of groups, powered and unpowered. Powered group includes three main subgroups, namely, gyrodyne, autogyro, and helicopters. Unpowered are mainly rotor kites. A gyrodyne is a rotorcraft with a rotor system that is normally driven by its engine for takeoff and landing, hovering like a helicopter, and its forward thrust is obtained from a separate propulsion device rather than from tilting the rotor. An autogyro, sometimes called gyrocopter, gyroplane, or rotoplane, utilizes an unpowered rotor driven by aerodynamic forces in a state of autorotation to develop lift, and an engine-powered propeller, similar to that of a fixed-wing aircraft, to provide thrust. Helicopters have powered rotors, single or twin. The rotors are driven, directly or indirectly, by engine that push air downwards to create lift. Rotors are driven by the engine throughout the flight, to allow the helicopter to take off vertically, hover, fly forwards, backwards and laterally, as well as to land vertically. The first helicopter flight dates back to 1907. The Frenchman Paul Cornu took off with a helicopter and hovered at a height of 30 centimeters for approximately 20 seconds. Continuous developments in helicopter industry lead to the extended list of helicopters. Helicopters have several different configurations of one or more main rotors. Each main rotor has a number of blades between 2 and 6. With a single main rotor helicopter, the creation of torque as the engine turns the rotor creates a torque effect that causes the body of the helicopter to turn in the opposite direction of the rotor. To eliminate this effect, some sort of anti-torque control must be used with a sufficient margin of power available to allow the helicopter to maintain its heading and provide yaw control. The three most common controls used today are the tail rotor, fantail, and notar. The tail rotor is a smaller rotor mounted so that it rotates vertically or near vertically at the end of the tail of a traditional single-rotor helicopter. The tail rotor's position and distance from the center of gravity allow it to develop thrust in a direction opposite of the main rotor's rotation to counter the torque effect created by the main rotor. Fenestron and fantail are trademarks for a duct fan mounted at the end of the tail boom of the helicopter and used in place of a tail rotor. Duct fans have between 8 and 18 blades arranged with irregular spacing so that the noise is distributed over different frequencies. NOTAR, an acronym for no-tail rotor, is a helicopter anti-torque system that eliminates the use of the tail rotor on a helicopter. Although the concept took some time to refine, the NOTAR system is simple in theory and provides anti-torque the same way a wing develops lift by using the Coanda effect. Twin rotors turn in opposite directions to counteract the torque effect on the aircraft without relying on an anti-torque tail rotor. The two rotors are arranged in tandem, transverse, coaxial, with concentric drive shafts or intermeshing. Tandem rotor helicopters have two large horizontal rotor assemblies mounted one in front of the other. Tandem rotor helicopters use counter-rotating rotors. This configuration is used for large cargo helicopters. Coaxial rotors are a pair of helicopter rotors mounted one above the other on concentric shafts, with the same axis of rotation, but that turn in opposite directions. This configuration is produced by the Russian Kamov Helicopter Design Bureau. Intermeshing rotors, sometimes referred to as a syncropter, are a set of two rotors turning in opposite directions, with each rotor mast mounted on the helicopter with a slight angle to the other so that the blades intermesh without colliding. The arrangement allows the helicopter to function without the need for a tail rotor. Transverse rotors are mounted on the end of wings or outriggers perpendicular to the body of the aircraft. Similar to tandem rotors and intermeshing rotors, the transverse rotor also uses differential collective pitch. But like the intermeshing rotors, the transverse rotors use the concept for changes in the roll attitude of the rotorcraft. Thanks for watching.